We are testing Armbian on the Orange Pi RV2 using the Debian-based distro with Xfce. It features a recent kernel and low idle RAM. Regarding performance, the processor test with 5 threads stands out with a very notable result compared to similar equipment. When preparing the files for the disk input and output test, it gave us an absolutely excellent sequential write speed result. We start by entering the Armbian website. Click on Boards, then expand the list and select Orange Pi. Then we scroll down the page. In the list of boards, we look for the Orange Pi RV2. Armbian suggests using Armbian Imager. We click on Downloads 2 times. In my case, it detects that I use Linux and downloads the app image. We run it. If you have any issues running it, you can watch this. Inside Imager, we select the brand Orange Pi, then the board Orange Pi RV2. We start with the Ubuntu Xfce edition. Then we select the microSD device. The image begins to download. Then it is decompressed. Then it is written and finally validated. Now we extract the memory and insert it into the board, the keyboard, mouse, the HDMI cable, and finally the official power supply. We expect the board to boot with the recorded image, but we only see a flash, and it fails to boot. We wait a bit, then power off. At this point, it could be several things to try again. We will download the image and write it with RPI Imager. Select the image, then the device. Then we enter the password and press Next. It will start writing the image, and then it will perform validation. We insert the microSD memory into the board. I also wanted to show you the M2 disk holes. Then we connect the power and wait now. We expect the board to boot with the recorded image, but again only a flash is seen. It fails to boot, so we turn off the equipment. It could be the flashing software. Now we use the original Orange Pi OS image used in this video, and as we can see, it did start. This original image brings an Ubuntu-based distro. Everything boots very well, so it is not the flashing software. Then power off. Let us remember that when we selected the image, this message appeared. This image is maintained by the community and may not boot. Now we download the image based on Debian 13 CLI, open Balena Etcher to test another flasher, select the image and the device. The flasher starts the image decompression, then the writing to the device, and finally the verification that it wrote correctly. Again, we take the microSD memory and insert it into the Orange Pi RV2. Then we connect the power supply and see that the light is on. Armbian does boot now. It asks us for the root password. Then we create an account by entering user, the password and full name there. It indicates that it did not detect Ethernet. And if we want to use wireless, we press yes. Select the network and enter password. Now it asks if we want language based on location. We say no, it presents the locales. We select it and then choose the location. Upon completion, the system boots for the first time from DSD, gives us system info and the command line for selecting CLI. We run Armbian config. It will show us the system configuration. We select System and it will show options related to the system. Now we select Desktop and it will show us several desktop environments of different sizes. We select Xfce in its minimal mode. Then the download and installation of the desktop environment on the system will begin. Remember, we are still using the microSD. We restart the computer and the system will enter login, enter user and password. Then it will enter desktop and run config tool. We enter the password and it will enter the configuration as we previously used terminal. We change font size and window size. We enter the system option, then we select the storage. Here it presents several options. We select the copy to another device mode. It performs device detection and then presents several options from which we select that it boots from MTD flash using NVMe disk. We select the target device, press yes and then OK for ext4, then the copy of the bootloader and the system to the disk will start. If you select the SD and NVMe option, you must always have the SD inserted for the bootloader. It asks if we want to write the bootloader. We press yes. Again, we press yes to confirm. Then we wait and power off the equipment. We proceed to remove the microSD memory from the board so that it boots directly from the NVMe disk. Then we connect the power. The system boots for the first time from the disk. We enter the user and the password. Then it will enter the configured desktop. We open Terminal, but before continuing we open the Settings menu, then Keyboard, and then we select the Keyboard Layout option. After selecting it, we remove the other layouts and close the window. Now in the terminal we enlarge the font size and window. We update the system with sudo apt update command. Then we execute sudo apt upgrade command. We wait for the process to finish. With the command sudo apt install, we install Fastfetch packages to see system info and Sysbench for the tests to be performed. Then we run Fastfetch. The kernel has a recent version. Idle memory and disk megabytes per package are absolutely excellent. Now, we execute commands to contrast the information regarding the version of the distribution, the kernel and memory usage. We also check the space occupied on the disk. Then, we verify the boot time by removing the firmware time, which is very fast. Now we run Sysbench to evaluate the system. We test the processor with a single thread. The result obtained here is average. We evaluate the processor, but with 5 threads to see its behavior in concurrency. The result of events per second is great. We test the threads directly with Sysbench to evaluate how the system handles concurrency. The result again is very good there. Now we evaluate the mutexes to see the efficiency of log handling using 5 threads. The result in comparison is excellent. We test memory reading to evaluate memory management. The result obtained is low compared to other distributions tested here. Now, we change the arguments of the command to analyze memory write speed. The result obtained is unfortunately very low now. Then, we prepare the files for a disk input and output test. This indicates an absolutely excellent sequential write speed. We run the test indicating that test mode will be random write and read. The read and write results are completely excellent. We run top and Firefox, but it is not installed. We proceed to install Firefox with sudo apt install command and wait to finish. Now we execute the top command. We run Firefox to analyze browser memory consumption per tab without loading extensions today. We open a second tab loading a video. With this we want to measure memory consumption when opening several windows as an average. Then we open a third and fourth tab to see the average memory consumed per tab. The average result obtained is truly excellent. We have finished the evaluation of Armbian Debian. We close everything and turn off the system. We will present the conclusions. Be careful with community images. Some do not work. We tested Armbian based on Debian, and the configuration is simple to follow. The performance tests give an overall result above average. Although we have not shown graphical performance, we did test it. But there are many incompatibilities, which did not allow running benchmarks like GLMark2, BigKMark or WebBaseMark 3D properly. That has been all for this video. If you liked it, subscribe, leave a like and activate notifications. See you in the next video.